All right, now we're going to move on to an introduction into array lists. To start with, we're going to start with this simple little method that has a scanner. We have a total. We keep reading in integers, adding them into the total. We keep doing that until we get to at least 10, and we simply print out the total. Let's compile this code, which compiles. Let's go ahead and run this code, and here we go. I'll do 1, my total is 1, 4, my total is 5, 3, my total is 8, and say 6, my total is 14, and it stopped running. This works great. Now what I want to do, though, is not only print out the total, I want to change this code so that it prints out an array of all the numbers that you entered. Okay? So the problem here is we don't know how large to make this array because we don't know how many, one time I'm going to run this and I'll just immediately enter in 14 and I'm done. Another time I'll run this and I'll do -1, -2, -3, -4, -5. Obviously, I can do this for a very long time before getting past 10 because I can add as many negatives as I want. So we have no idea how many numbers you're going to enter and no idea how large to make the array. One way to handle this would make the array huge. And just allocate one array, but that feels wrong. Another way to do this would be to make the array zero-sized, right? And every time that you enter in a number, we'll also add it to the array. You want to do something like that, but you can't do that, right? By the way, let's also do system out print line arrays.toString array. Okay. So we try to compile this, and you cannot add a value to an array. So what you have to do is, because the array only has room for exactly as many elements that are in it, you actually have to create a new array equals a new array of 1 larger, and then I is 0, I is less than a.length, I plus plus, b of I is a of I, copy all the values into b, then we can say b of a.length, the last element is next, and finally we'll say a equals b to store that array back at a. So what we're going to do here is create a whole new array, load it up with all the values. Maybe this would look nicer if we did this. Load it up with all the values in A, add that next value to the end, and then set A equal to that new array. So now we compile, and we have to do import Java util arrays, compile, and it works, and we run, and we'll do 1, 2, 3, 4, and sure enough, it printed out 1, 2, 3, 4. So this works, but it's gross. It's gross for a couple of reasons. The main reason, first, I think having to copy in all those values over and over again is gross. But also, we had to create an array of size 0, an array of size 1, an array of size 2, all these arrays. Now, if you're only doing an array of 4 in the end, that's not so bad. But let's say we're going to enter an array, 1,000,000 integers. It might take us a while, but let's say we're patient. Okay. Well, how many different arrays did we have to create? We'd have to have created 1,000,000 different arrays, even though in the end we're only using one of them. That should feel wrong to you, inefficient. There has to be a better way, and there is. The problem is that arrays are not dynamically extensible. They don't grow. But there's another type that you can have called an array list, which fixes this exact problem. So instead of this line here saying I have an array of integers, we're going to say that I have an array list of integers, and let's call it A, is a new array list of integers. And this line works basically the same as this line, only instead of it being an integer array, an int array, it's an integer array list. Two things. First, integer. Array lists only work over non-primitives. over objects. That's why we did the whole wrapper class, so we could create array lists. Second, array list, not array. Array lists grow automatically for you. Okay. Third, over here, we had to do this array list of integer in these parentheses. So a little slightly syntactic difference in how you create them, but it's the same basic idea. Now, down here, things are about to get a lot cleaner. We don't need to create a new array. We don't need to copy all the values in the array. All we have to do, instead of all of that code, which is going to blow away, is just say a.add of next. And now instead of printing arrays.toString of a, you can just print out a because array lists know how to convert themselves into strings as well. We compile and we run 2, 4, -1, -3, 17, and look, it works perfectly. And if you notice, we only create one array list ever. It resizes automatically. This is just much cleaner. You just have to be careful that we are not storing ints inside this array list. We are storing integers. And as the previous part of the lecture made clear, integers don't always quite act as ints. And once again, to show you this isn't going to work, let's try to do it with a primitive. We compile, and it says, sorry, it must have a reference, not a primitive type. So it must be integers there. And so this code right here shows clear as day why array lists are something that we are interested in.